Cool, so now that you've seen the single open parenthesis, get ready for the double open parenthesis. Now I've talked about this before. This is arithmetic expression or being able to deal with math in Bash. If you want to look up the help page for it, it will tell you to look up the help page for let. When you look up this is all the sort of stuff you can do here. I plan on going through it all real quick with you just to show you what's going on here. So let's make our own script. Arithmetic expression. Am I pronouncing that right? Is it I always say arithmetic, but I don't know if it's arithmetic. I don't know. You guys can tell me if I'm pronouncing that right or not. So we're going to use math expression. There we go. That's safe, right? Just avoid the word altogether. Cool. So what's the first thing we can do? Well, you know how we can say thing equals command here? And we can just put whatever command we want here. The reason it turned orange is because command is actually the name of a command in Bash, so it recognizes that. But we could put anything here. We could put uname, we could put who am I, you could put date, you could put whatever command here. Well, we can use double parentheses. Notice the $ in front of it, because this will expand it using the math syntax. So we can put anything in here that we want that's mathematical. You can put spaces, not put spaces, whatever you want. It's a stylistic choice. So we could do 2 plus 2. Again, the spaces are optional. I'm going to leave them in there just because it makes it easy to see. So we could say thing is $thing. We go ahead and run arithmetic expression. We can't tab complete it because it's not executable. So chmod plus X. Now we can tab complete it because it knows we're trying to run it. So if you're having trouble tab completing a program like this, you're trying to execute directly, make sure to check that the executable bit is there. We run this and thing is 4. Hey, that's awesome. No trickery there, right? We can do this on our shell if we want to. Sometimes I end up doing quick math like this, where it's like, oh, what's 57 times 2? I run this and it's 114. That's awesome. What's 57 to the second power? 3,249. There's some heavy wind out right now. I think I just heard a tree branch hit my roof. That's awesome. Hopefully nothing breaks. All right, let's keep going. The nice thing about math is you don't even have to have an expression here. You can just say, like, I don't know, 42, and you run it, and it will just resolve to 42. Like, that makes perfect sense, right? Let's go back into the script, and let's start doing some fun things here. Because we can do, let's say, A equals 2, B equals 3. We can echo $A plus $B. We can even use variables, and look at this. It works. I said it works before I even run it. I should be more cognizant of that. So we get 5 because 2 plus 3 is 5. That's awesome. Again, when you are in mathematical expressions here in Bash, when you are doing arithmetic expression, you don't need the $ here. You can just use these. It understands variables and it will resolve them for you. So that is pretty cool. Something to keep in mind though, this is something to be mindful of in Bash. It's not really strongly typed. There is a way of declaring integers, but they're kind of weird how they work, so I'm going to stay away from them here. If you're interested in looking this up, look up declare-i. You can technically create integers, but I've run into all sorts of problems with them, so I stay away from them. But if I were to say A equals hello and B equals goodbye, I'm setting them equal to strings, and then I'm going to do math on strings. What do you think is going to happen? Well, we get 0. When it can't be parsed as a number, it usually ends up being treated like a 0. This sucks. This will be the source of a lot of bugs. I'm sorry. That's just how it's going to work. So you might have to check your expressions. If you are taking numbers from a user, you may have to check that what they gave you was a valid user. I can talk about how to do that later in the video, but you might want to check, like, you know, does $A equal 0 through 9 star or something like that. Yeah, so when you put the $ in front of it, that means to evaluate it and print the result. You can actually omit the $. It's invalid after echo here, but you can put it here, or you can put it in a for loop or a while loop like you've seen. But you can just do this here, and this will have a side effect. So it'll run that code, and then we can just say echo done here. If we run that, it won't print anything, it'll just print done, but this expression actually did work. So you could say something like C equals A plus B. You could do it like this, and you could say C equals $C. Let's quote this just to be good. Go ahead and run this, and we can see that C equals 0. Of course C equals 0 because I forgot that I set these equal to words. 2 and 3. So if this all works, C should be equal to 5. There we go. That's awesome. That is super useful. The reason it's super useful is because we can do stuff that you might be used to. Let's get rid of A and B, and let's do I. I equals 0, I plus plus, and then we can check what I is equal to. So here's a script, and if we run it, look at that, I is equal to 1. So we have post increment, we have pre-increment, we have all sorts of fun things like that. We could take this I, and we could do something like times equals 5. And let's go ahead and change this from 0 because 0 times 5 is 0. Let's make this 2. So if I times equal 5, we should get 2 times 5. I should be set to 10 at the end of this. If we run this, I is equal to 10. That's awesome. We also do have shift operators, so you could do like shift equals. So you could take 2 and shift it to the right 5 times. And then you run this, you get 0. We could shift it to the left. Ooh, wow, that got all messed up. Shift it to the left 5 times, we run that, and now we get 64. That makes perfect sense. So it's kind of wild what you can do. You can do all sorts of fun operators with this. This is a super useful thing to know because the math that Bash supports is surprisingly robust. You can do a lot here. We have logical operations. We can do bitwise OR. We can do XOR, bitwise AND. You can do modular division or remainder division, exponents, bitwise negation, logical negation. There's all sorts of fun stuff you can do. You can even do ternaries. Bash does not have ternaries normally, but in this syntax, it does. And this is really cool because we could make our own little like max function. So we could say, you know, A equals 2. Let's do the basics. B equals 3, and then we want to get whatever the max is. We could say max equals, if A is greater than B, then we want to set it to whatever A is. Otherwise, we want to set it to what B is. If you've never seen this syntax before, I'm very sorry. It's called a ternary operator. It's in a lot of different languages. Now we can say max equals $max, but all we're saying is run this expression, and what comes after the question mark is if the expression resolves true, and what comes after the colon is if the expression resolves false, and we save that into the variable called max. So we run this, and we should get 3 because 3 is the greater of those two options. Perfect. So that's our own little max function determining which number of 2 is bigger. Now, there is something to be mindful of here, and this is something that trips a lot of people up, especially if they do set minus E in their scripts. I will talk about that later in the video. I do have a video dedicated on my YouTube channel specifically to this because this causes a lot more problems than it's worth. That's my personal bias when it comes towards it. And one of the issues I see from that is people don't realize that this expression has a return code, meaning this can fail. Now, in Bash, if something just fails, if a command fails, we just move on to the next line. That's totally fine. But if we were checking it or looking at the return code, some things might not work how you expect them to. So what I mean by that is if we have, let's say, 2 plus 2, we can echo $question mark. In fact, you know what? Actually, I'm just going to do this in the command line. It's easier to see it here. 2 plus 2. We run that, and it evaluated it. It didn't save the date anywhere, but it evaluated it. So let's go ahead and look at the return code. It was 0, meaning it was a success. 2 plus 2 is a success. Why am I stressing this? Because what about 2 minus 2? That is a failure. Super weird, super bizarre, but you have to shift your mind into thinking like C. If you have if A minus B, then something like that in C, it will check if the answer is 0, then the if statement fails. And if the answer is true, then the if statement's true. That's why it works this way. So I can write code in Bash where I can say something like, let's say A equals 10. I can say if A modularly divided by 2, then echo something else, echo something else, phi. So this might be kind of confusing, and this is a little contrived. I would never actually write code like this, but I'm going to show you what happens when I run it. We're not going to sit here and try and figure out what it does. We're going to explain what happens by running it through some examples. So print something else. So that means that if you do 10 modularly divided by 2, it is a failure. Why is it a failure? Because 10 modularly divided by 2 is equal to 0, and 0 is considered a failure inside math expression. This is the confusing part. When the answer is 0, it returns a failure, and a failure to Bash is non-zero. So it's a little bit negated from how you're thinking. If the answer is 0, it's considered a failure in terms of the if statement. So effectively, we could change this something else to like number is even, and we can do number is odd, and now we have a basic is even is odd detector. So if I run this, we can see, okay, 10 is even. That's awesome. What about 11? If we run it against 11, number is odd. That's very simple. Again, I wouldn't write code like this. I would do something like this. I would check very specifically, and then I would negate these. So if you modularly divide it by 2 and it's equal to 0, then we can say that number is 0 or number is even. I like to be very explicit when I code things like this, but I'm just showing you that this, the result of this can be tested against. That arithmetic expression in this sort of format does have a return code. This trips people up because people will have code like this. They'll have I equals 0 while I is less than 10, which is totally valid. You can write code like this. and then at the bottom of their loop they'll have I++, and we can say echo I is $I. And that's all well and good. We can run arithmetic expression and we get I is 0, I is 1, I is all the way up to 9. Now there is something I haven't told you about, but you may have seen this before. Some people like set minus E, which is Bash's way of exiting if there's an error, and people claim that, oh my god, this makes your Bash scripts more robust. Maybe it does for some people, but it also causes you to exit early because the output, the return code of this expression is a failure the first time it runs because the answer is 0 when it's 0++. Even if you're thinking, wait, 0++, doesn't that resolve to 1? Yeah, but it's a post increment, so it resolves to 1 after it's already considered. So it's like a gotcha on top of a gotcha here. So I might talk about this more later, but just get rid of that and we're good to go. You might run into some bugs, but hopefully by following this course, I can help you work your way out of them and not get stuck by them. There are also some more things to consider with arithmetic expression, just some things to be aware of. There's a lot of things it can do, and it is very powerful. With that, it can also be kind of confusing. So if we have a string with like leading zeros, for instance, we have A equals 06, we can do something that we could echo $A, we can just print it to the screen, and then we can echo, what is it? A like this. So we just treat it like a number. And what happens when we do this? We echo 06 because that's what the literal string is, and then when we treat it like a number, it's 6. Hey, that makes sense. It just stripped off the leading 0. That's super convenient. What if we make this a 7 and then we run it? Hey, that's awesome. It strips off the leading 0. That's so great. What if we make this an 8 and we run it? Oh, that's super weird. That's not what I expected. Arithmetic expression, when it detects a leading 0, it treats it like octal, meaning base 8. So the number 8 is too high for octal. That's what's happening here. That might be confusing to you. You would have to do something like this. 010. This is not binary. This is this is not hex. No. This is not binary. This is octal. This is base 8. So that means 1 in the 8's place and 0 in the 1's place. So we will have 1 8 in this, meaning this should resolve to the number 8. And if we run this, that's what we get. So be aware of leading zeros. They can cause you problems when you're trying to deal with them in a mathematical way. There are ways to get around this. You can force it into a specific base. So if you know what the base is, you can do 10 £. Now the pound sign is valid. It won't consider it a comment. Don't worry about it. It's inside this expression notation, so it's not considered a comment. 10 is the base. We're going to say force this to be base 10. And when we run it, oh, we still get an error. What's going on there? This is the time where we have to put a $sign here. I'm sorry, it's weird. Bash is full of weird rules like this, but you need the $sign here. We need to basically turn it into the 08, or sorry, the 010 in this case, and then we'll force it into base 10. And then look, it treats it like the number 10. That's what it knew it was getting. This also works if we were to go back to like 08. Remember this one broke it before? We run this and it treats it like the number 8. So you can use bash to force it into a specific base. This is helpful. You can also put like 16 in front of it if you want to do conversions between like hex numbers and things like that. So super convenient. Arithmetic expression, very powerful and very useful when used in conjunction with like while and things like that to do sort of looping and stuff.